So a tree diagram, it's an easy way and a helpful way to organize and visualize outcomes. So I love tape diagrams, I love drawing pictures, all of those things, because it helps make the math visible. And so that's what a tree diagram is. So I'm going to read example 1. It says, imagine that a family decides to play a game each night. They all agree to use a tetrahedral die, a four-sided pyramidal die where each of 4 possible outcomes is equally likely. Each night to randomly determine if they will play a board game, B, or a card game, C. The tree diagram mapping the possible overall outcomes over 2 consecutive nights will be developed below. So to make a tree diagram, first present all possibilities for the first stage, in this case Monday. So Monday is our first option right here because the week starts with Monday, depending on how you look at it, but in this case it starts with Monday. And then the next day would be Tuesday, and we're looking at 2 possible days. And then the next thing is our options are a board game or a card game. So that's what's listed here is Monday, board game, or card game. So then thinking about Tuesday, on Tuesday, regardless, if they play a board game, the options on Tuesday are a board game or a card game. Also, if they played a card game on Monday, the next day the options would be board game or a card game. And then the outcome, we would look at it like this. So kind of thinking like a Punnett square in science. And I'll insert a picture here of what a Punnett square looks like, but thinking about like a Punnett square, this is kind of the same thing. Where if on Monday they play a board game, on Tuesday they could possibly play another board game, so board game, board game. If they played a board game, they could also play a card game the next day. If they played a card game on Monday, they could play a board game the next day. And then if they played a card game on Monday, they could end up playing a card game the next day. There are no ways for us to control what's happening because the outcomes are equally likely. There's a possibility of playing a board game or a card game regardless of what they played the day before. So this is what a tree diagram looks like. This is the focus here, is just creating this and being able to visualize exactly what the options are using our sample space. So again, our sample space was board game and card game. Flipping the page. So here, all they've done is complete the tree diagram as if exactly how we just did it. So it says, note, if the situation has more than 2 stages, this process would be repeated until all stages have been presented. So what that means is if, let's say they went to Wednesday, and I'm just going to pretend that this isn't here because you have it on the other paper, you would just do the same thing for all the options. It's just, again, board game, card game, board game, card game, board game, card game. That's it. That's what it means. So if BB represents 2 straight nights of board games, what does CB represent? That represents, CB would represent a card game on Monday and board game on Tuesday. List the outcomes where exactly 1 board game is played over 2 days. How many outcomes were there? So again, where exactly 1 board game is played over 2 days. So this is asking us when are the times where one night they played a card game, one night they played a board game. So that is looking here, BC and CB. 2 outcomes. So here's our introduction to a tree diagram. We will go deeper into this tomorrow, and then you will have your exit ticket. For today, I want you to practice by uploading your own tree diagram for the problem that I'm gonna present, and then going from there.